A lot of information can be obtained from the graph of the function, as you've seen already. In this particular example, we are given a function, and notice we are not told the equation that defines that function, but we're asked to find f of -4. If you recall function notation, that -4 is the x value. Since we don't have an equation to substitute that in for, what we will do is go to the x-axis and go over to -4. Now what I want is the point on the graph of the function that corresponds to x equals -4. So notice if I go down and I look right here, the point that corresponds to x equals -4 is this point right down here. This point also corresponds to the y value of -4. So we say f of -4 equals -4. Now that's not always going to be the case where the x and the y are the same. So you will just have to try to figure out which x value point on the graph corresponds to the y value. Now we're also asked to find the domain and range. The domain, remember, is the x-axis values. If you will notice, this graph spans the entire x-axis. I know it has some low points and some high points, but it starts way over here on the left and it continues way over here on the right. And that's the way that the x-axis travels, left to right. Since it covers the entire span of that width, left to right, we say the domain is negative to positive infinity. However, the range would be the y values. The y values would actually be the height. How high and how low does this graph ever get? The highest points you will notice are these hills, these points on top, and they go to +5. The lowest values down here go to -5. So we say that the range, the y values, range from -5, +5. Now I put the negative one first because if you recall, interval notation always puts the negative or the smaller value first. Another important way we use functions is with a special type of function called piecewise. Piecewise means that it has more than one part to it, or pieces. Okay, right there, piecewise. Notice that we have two particular pieces or parts to this particular question. Now, how do you work a piecewise function since it basically has two different equations? Well, it all depends on the x value. Look at your x value and see which condition it should be used with. In this top part, f of x equals 5x minus 3, you would only use that if your x is less than 0. Now think about all the numbers that are less than 0. That would be numbers like -1, -2, -3, -4, all the way to -infinity. You would only use the second part, f of x equals 2x plus 7, if the x is greater than or equal to 0. So that would mean the numbers 0, 1, 2, 3, 4, 5, all the numbers up to +infinity. So it all depends on what x you start with. Since my first x with example A is a negative number, it must be used with the top or the first part. So I will say f of -4 is equal to 5 times -4 minus 3, and I will work that out, and my final answer is -23. Just because the piecewise function had two different parts to it, I do not get two answers for one problem. I get one answer. You will get the wrong answer if you use the wrong part. Now, my second example has the x value as 0. Which one, the top piece or the bottom piece, had the 0 listed for x? That is correct. It would be this bottom piece. Remember, these are the x values. So I have to use the bottom piece here. So I will say f of 0 equals 2 times 0 plus 7, and I'll work that out. and I get 7. Again, a single answer. And last but not least, I have part C, and that has the x as a positive 5. Well, positive 5 is up here in the second line. That would be the second piece, the second part of this. So I would solve it as f of 5 equals 2 times 5 plus 7. That gives me 10 plus 7, which is 17. Again, one answer for one input. Now we're going to talk about the difference quotient, which is also called a rate of change formula for any of you who've studied pre-calculus before. This is a quotient, a difference quotient that you will use to find the derivative when you take a calculus class. Since this course leads students into calculus, we do cover it as a prerequisite. Now, to find the difference quotient, there are two different parts. First off, we need to be able to calculate f of x plus h. So I take my original function that will be given, and I want to substitute x plus h in the original function everywhere there was an x. When I distribute, I end up with negative 2x, negative 2h, and plus 5. So that's the first part of this problem, finding f of x plus h. The second part of this problem is going to be to use this formula. This formula is called the difference quotient formula, and that's the one we're going to use. Now, notice the formula takes what we have in part A here. So I will put that quantity first. All right, that's the quantity we had from our part A answer. Do part A first. Then it will subtract f of x. Now, minus f of x means that I'm going to subtract the terms in the original problem. So I'm going to subtract negative 2x plus 5. And in the denominator of this formula, you just put the letter h. Now we'll simplify. I already had 2x minus 2h plus 5 from what I had worked out over here in part A. The formula already has the letter h in the bottom. Notice right there. So in this second part, the only thing I really have to do is to subtract the original terms from the original function, which basically means change their signs, because negative negative turns that to positive 2x. And when I subtract that positive 5, that turns that to negative 5. Now I will combine like terms. I notice that I copied something wrong. Notice here I should have a negative 2x. That should be a negative. I just copied that wrong. Even your teacher can make a mistake. Be careful on that, those pluses and minuses. Okay, now, what I was about to say before I realized my mistake is I need to combine like terms on the top. I noticed that the negative 5 and the positive 5 cancel out because they equal 0. The positive 2x and the negative 2x cancel out because they equal 0. You should have a lot of canceling in this step. What I'm left with is a negative 2h on top and an h on bottom, and guess what? The h's cancel out, so that really just leaves me with negative 2. Your final answer is negative 2.